So now in this lecture, we shall help us understand, how to calculate the tension and shear capacity with the help of just a simple calculator, with no as such, fancy Excel files required. So let us just proceed with, let us say if you want to proceed with M20 bolt. So considering M20 bolt, we do know that the area, the tensile area of that particular bolt is 245 mm square. So we do need to enter 245, multiply it with the tensile strength of the bolt. In this case, in this particular part, we are considering 4.6 grade. So that is approximately 400 Newton per mm square. And then again multiplied with 0.8. So that number again divided with the 1000 to find out the value in kilonewton. So this is how we can calculate the tension capacity of the bolt, and here it is also 78.4 and here also it is 78.4. Similarly, we can pick up the largest diameter. Let us see if we want to calculate it for the M36 bolt, 36 dia bolt. So what we need to do is that 817, that is a tensile area, multiplied with the 400, and again multiplied with the 5, that is the capacity reduction factor, divided by 1000. So the number comes out to be 261.4 kilonewton, the same number that we are seeing here. After that, if you want to calculate the shear capacity, so shear capacity is also very simple, but instead of, it do depends whether the shear plane is on the threaded area or on the non-threaded area. If the shear plane is on the threaded area, we do have to consider the, we can say, core area. If not, we have to consider the shank area. So obviously shank area capacity here, you can say that is much higher as compared to the what we can say as the core area capacity. So let us just assume in the first trial that our shear plane is passing through the, we can say, threaded portion. So we'd have to consider the core area itself. Let us just proceed with the largest diameter. So what we need to do is 759 multiplied with the, we can say, the tensile strength of the bolt, that is 400, again multiplied with 0.62, that is the factor that is given, and KRKD we can assume it as 1. And after that, what we can do is that we can multiply it with, again, with the capacity reduction factor, that is 0.8. So the number comes out to be approximately 150585 in Newton. So we have to divide it with the 1000 to find out the value in the Kn, that is kilonewton. So here you can see that 150.5 and 150.5. So you can, prepare an Excel file also at your end. It just takes a minute. It shall just take a minute of your time to find out the or to calculate these values. Yeah, now if we're talking about the core area, we already have, consider that. And after that, if we're talking about the shank area, that is 201.5, we can also calculate that. That is 1016 into 0.62 into, we can say, 0.8 divided by 1000 and multiplied with the 400. So the number comes out to be 201.5 kilonewton. Again, I'm doing the calculation. 0.62 multiplied with the tensile strength of the bolt, that is 400, multiplied with the shank area, that is 1016, multiplied with the, we can say, the capacity reduction factor, that is 0.8, and after that we can divide it by 1000, 201.5 kilonewton. So that is the same value that is written here. Similarly, we can do the same calculation with the 8.8 grade bolt also. That is, instead of 400 tensile strength, we do have to consider 800 tensile strength here. So and again with the similar calculation for the 10.9 bolt also, 10.9 grade bolt also. So the calculation is very simple. We do have to deal with just two formulas if if you're doing preliminary calculations before you proceed with the detailed in-depth analysis and design of the bolt. A simple calculation, let us say you are having a case where you want to handle, let us say, 400 kilonewton of the shear, pure shear. There is no as such tension, or if the tension is there, that is negligible. So if we have to attend to 400 kilonewton of pure shear, what we can do is that, let us say we do have 62.3 bolt, or let us assume that it is passing through the threaded portion. So let us assume we do have 200 kilonewton. We can divide it by, let us say, 44.6. So we do get approximately 5 number of bolts. So we can increase it to 6 number of bolt in that case. Second and the most important thing is that in the connection bolt, we never use 4.6 grade. So we can scroll down to 8.8. So let us assume in the same case where we had to have 200 kilonewton of pure shear, we can divide it by, let us say, M16 bolt capacity, that is 59.3. So we do need approximately 4 number of 8.8 grade of M16 bolt to attend to 200 kilonewton of pure shear. That is a preliminary calculation. We do have to do the detailed analysis, but just to start, we can do this kind of, we can say, uh, preliminary analysis. Similarly, let us assume we do have 1000 kilonewton of pure tension in a particular group of bolts. So 1000 kilonewton that needs to be divided with, let us assume we want to proceed with the M20 dia bolt. So the capacity of one bolt is 162.7. So we shall need approximately 6.1, or we can say 7 number of bolts to attend to that much 1000 kilonewton of pure tension. And obviously, when we're talking about the interaction, we had already studied in the earlier lecture that how we can calculate the interaction formula, that is this particular formula, and how we can assure that under the combined action under the clause 9.2.2.3 of AS 4100, the design is safe.